Okay, so in example 1, you saw how we basically used row echelon form and we solved systems by making it into the triangle shape. And basically what we're going to do now is we're going to use the augmented matrix and actually use matrix operations to do the exact same thing. So just a little bit about row operations. This is stuff you're allowed to do with matrices to make an equivalent augmented matrix. It's basically the same as what we had on the page before in terms of what you could do for equivalent systems. You can interchange any two rows, you can multiply one row by a non-zero number, or you can add a multiple of one row to another row. So down at the bottom of page 366, they've got sort of a nice little example of what you're allowed to do. Starting with rows 1, 2, and 3, you can switch two of the rows. You can multiply one of the rows by something, or you can basically take a multiple of one row and add it to another, and then replace it with that. So if you look at the top of page 367, you'll see that basically what they've done is they took the putting it into row echelon form, which is what we did in example 1, and they're showing you now how you could do that in an augmented matrix. And you'll notice here that you sort of come up with the same idea down at the bottom where you start with 1, 1, 1. Here you've got X, Y, Z, Y, Z, and only Z. So basically we're going to do what we did in example 1 now to a matrix. Or at least that's going to be our goal here in a little bit. First thing you need to know is it in row echelon form? So basically a matrix is in row echelon form if the following conditions are met. Rows consist entirely of zeros, if any appear at the bottom. So basically here, if you have all zeros, it needs to be at the bottom. The first non-zero entry in a row is 1. So basically each row has to start with a 1 unless it's a 0. And then for two successive rows with non-zero entries, the leading one in the higher row is farther to the left than the leading one in the lower row. So basically, I'm just going to show you this example here. Determine whether it's in row echelon form. The answer here is yes. Basically, each row starts with a 1, so that one's fine. This one, each row starts with a 1 and all zeros are at the bottom, and for each row, remember the 1 in the row above it has to be further to the left, and it is. So it doesn't matter that there isn't a row with a 1 here, that's okay. Alright, this one is no good, because you'll see here that these ones are in the same position. In order for it to have been in row echelon form, really you would have needed 0, 0, and then the 1. So this one is not in row echelon form. Okay. I'm going to go ahead and talk about the guided practice in a separate video, but I am basically only going to reference the book and just talk about them. So go ahead and try the guided practice and then quickly view the video to make sure your answers are right.